So today we're just going to add a little bit on to the binomial probability theorem stuff that you learned yesterday. So if you look at the scenario, it says Joey forgot to study for his bio test. He decides his best bet is to randomly guess on the multiple choice section. There are 5 questions and each question has 4 choices. What is the probability that he gets at least 4 right? So what's different today is this at least. So if he gets at least 4 right, that means he could either get 4 right, or he could get all of the questions right. So the only difference is we have to find each of those probabilities separately and then just add them up. So let's talk about if he gets 4 right. If he gets 4 right, we need to do the combination. How many ways could he get 4 questions right out of 5? So that'd be 5 combination 4. The probability of success is the probability of getting the question right. And since each question has 4 choices, it's going to be 1 out of 4, or 25%, or 0.25. And he needs to get 4 of them right, so we're going to raise that to the 4th power. And then that means that his last choice has to be wrong. So the probability of failure that he gets it wrong is going to be 3 out of 4. And we want that just to happen once. So you can put a little exponent of 1 if you want, or you can just leave it as is. And then you just put that in your calculator. All right, if we do that, we get about 0.015. So basically he only has about 1.5% chance of getting 4 of them right because he's randomly guessing. And then we have to take the probability of getting all of the questions right. We could, if we want to, do another binomial probability theorem, but basically there's only one way of getting 5 questions right. So we don't necessarily have to do this right here. And then also, we won't have to do both probabilities because we're hoping only for successes. So if he gets all questions right, that would be 1/4 probability for each question, times 5 times, and then we can get that probability. And that's a really, really tiny probability. About 0.001 or 0.1%. So he does not have a very good chance of getting all 5 questions right. And then what we want to do to get the total is just add those up. So combine this and this together, and our final answer should be about 0.016, or about 1.6%. So if you have some question like at least or less than, you just have to find the probabilities separately and then add them up. All right, we'll just look at the last question. It says, what is the probability that he gets at least 1 question right? So if we did that, what we could do is find the probability of getting 1 question right, 2 questions right, 3 questions right, 4 questions right, and 5 questions right, and add them up. But the quicker way would be to figure out the probability of getting no questions right, and then everything else that's left would be the probability of getting at least 1 question right. So let's find the probability of getting no questions right. We can do the whole binomial probability theorem like this, but it's going to be more simple in this case, kind of like this one right here. So there's only one way he can get no question right. So if we did the combination, we would end up just getting 1 anyways. So if he doesn't get any questions right, we don't have to worry about any probability of success. If we did 1/4 to the 0 power, that would just give us 1 anyways. So we take our probability of failure, which is 3/4, and then we want that to happen, in this case, all 5 times. And then you just put that in your calculator. And we get about 0.237, or 23.7%. So this is the probability that he doesn't get any questions right. So the rest of the time, he's going to get at least 1 question right. So we can change this to a percent and subtract it from 100, or we can take the decimal and subtract it from 1. And if we do that, we get about 0.763, or about 76.3%. So today you're just going to focus on a little bit of practice. Some of them will be similar to yesterday's problem, and some of them will be a little bit harder. For example, there's one problem where you have to find the probability of success or failure first, and then there's another problem on here where you might have to combine multiple probabilities, like the problems you just saw in this video.